Okay, I'm. Can everybody see the slides?
Yeah.
Yeah, it's customary to
Yep.
always ask that anyway, so I think you could.
Good.
But so the prospect, the issue of a judgment has, I think, is one of the pillars of intelligence. So, I mean, to me, when I approach AI, the mind, intelligence, it's kind of based upon understanding, reasoning, and judging. And understanding we covered a couple of years ago, I thought that in a pretty good uh, event. And reasoning we haven't done yet. Judging, there's already been two prior events. But what I've been having a hard, it's hard for me to get my mind wrapped around this, and I don't have the answers. This is kind of like a good Sunday philosophical exploration rather than, I'm going to present some kind of answers kind of a thing. But just as a by way of a kind of introduction, um, I think of a judgment as it could be something else. So that's the main consideration. So if it's a really simple situation and the decision is kind of a given, then that's not really the concern right now. That's important, but it's not the concern right now. It's if a machine can come up with a different judgment than the one that it has. And so in undertaking that, I hopefully within the context of this event, we can try to characterize the problem some more and look at, some possible solution designs having done that. So just as a quick review of the first event, which was now a couple of years ago, what I did was I read a large compilation of basically essays, studies, papers on judgment and decision making. The book is called The Handbook of Judgment and Decision Making, and I've just highlighted some of the points that I thought were the most important to me anyway, that kind of stood out. Mostly, it's that I came away with this feeling that AI, whatever we do, we shouldn't really make it like a human judgment. I mean, I guess there's arguments for that, but there's a lot of problems too. Like in general, people are overconfident in their judgments. Heuristics and biases, we all use that. They're fast. I think I'm going to do this. So in the same case, we reapply the same thing a lot. A lot of people get too wrapped up in their own inner deliberations, and not enough attention is paid to the external evidence. So there's some major themes that keep coming through again and again in this, and the upshot is that, I mean, in computer science and statistics, the stuff they teach us in college or wherever, or high school or wherever you want. I mean, basically, it's how to maximize something. You're always looking at how to get to the top of the graph, but the reality is we don't think that way, and maybe we shouldn't. Anyway, that was the first. I'm just reviewing the first uh, event. The second one, the second event, I tried to get my mind around what is it that's bothering me about this, because it seems like a real judgment has kind of a free will aspect to it, and there's definitely an element of intuition, but some of it's conscious reasoning too. And in a lot of different dimensions, there will probably be uncertainty, and people weigh the different uncertainties in different fashions. And um, it's difficult to tell in a system what's a fact, what is a fact, and what's a judgment. Um, so I want to just try to characterize what I've been kind of feeling about this. What I call a true autonomous AI judgment. True meaning authentic, not just the opposite of false. But um, so I listed some criteria here. So if there's a scarcity of evidence to look at, um, impartial, incomplete evidence, that's one thing that would tip you off that the machine is going to make a possibly difficult judgment. If the machine has not been trained specifically on whatever the problem domain is, that would be another criteria. If there's no hard-coded rules, etc. You know, if nobody sat down and programmed for the machine exactly what to do in some situation, then it's probably more of a real judgment. And the immediate and ultimate outcomes could be difficult to foresee. So reinforcement learning might not be, effective. And there's probably going to be, if a human would make the same decision, there might be a lot of intuition and biases, at hand. So I want to pause right here and try to see if everybody's kind of on board with the potential difference between a more or less mundane judgment and what I'm trying to classify as a true judgment. Are there any comments? Let's see if I can.
Um,
There's a quote that I can read maybe that'll get you thinking about this. And there's a movement called decision making under deep uncertainty. It's not new, but I really like this. And it's they say deep uncertainty is characterized by an inability to make well-informed future projections of a system based upon available data and understanding, and inability to reduce this uncertainty by gathering additional information. Common examples include situations where the probabilities of different outcomes are unknown. Previous data is deemed insufficient. So, I mean, you can't really train it on everything in advance. Experts might disagree on the consequences of different.
so
Kind of a further characterization.
yeah, um, what comes to mind is like the Bayesian brain hypothesis, like predictive processing, and that according to that, our brain is optimized, or the whole purpose of our brain is to minimize surprise. And when it comes to ML models, it seems that Bayesian, um, you know, theory and taking weighting evidence based on that is the optimal approach to weighting any evidence. Um, so I don't know. Is that maybe you can contrast like Bayesian theory to what you're talking about in terms of true judgment?
Well, in Bayesian theory, I think you have to have a prior probability. Usually, you have to have a prior probability established. So you've got to have a that unless it can learn dynamically. The way I understand, and I'm not an expert by a long shot, but for Bayesian theory, I think you're supposed to have like an expert determine what the prior probabilities are, and then those are taken up into the graph, and then it's updated with it dynamically with events as they occur. But Lance, so what if nothing, what if you've got some situation where you don't have a prior probability?
Um, so Jeff Hinton was interviewed fairly recently, and um, he basically said that LLMs prove that human intelligence is just comes from a gigantic prior, meaning that we just have, you know, so much training data that everything that we make judgments on is basically what
Okay.
falls within that is in.
Did he demonstrate such a system?
I don't know. I mean,
Yeah, I get what you mean. I get the meaning though, and I've got some comments about that frame of mind coming up too.
sure.
All right, thanks. Any other comments? Basically, I'm just trying to get everybody's mind wrapped around what what the problem may be. It's kind of hard to know these days because we're with so many great successes. Where do large language models top off? I mean, where do they get confused? Um, Okay, so I guess if there's no more comments, I'll just keep trying to breeze through this. So
I have a
the
quick
agenda.
question on,
Oh, yeah.
I just have a quick question on the judgment policy for AI for the individual versus a group. It seems to me that most of the questions rely around having the AI model trained on a large data set where it doesn't really uh, particularly matter to the particular user as much, and how you weigh the judgment policy depending on a user versus a group, kind of the philosophy.
Yeah, I mean, it's a great issue and problem. I think, I mean, a lot of people are trying to get around that now with graph networks and things like that. So it could be, it can learn dynamically what preferences are, I think.
So I just came back from Salesforce.com's admin conference, and they're really pushing use an LLM that's only living in your data, so your data is private and secure. That's a data privacy thing, but also um, sort of preconditioning what's important, what the data is, building the LLM or the Copilot, and then having it work on data with tasks and jobs that it knows how to do, so that they're trying to eliminate a lot of the
Yeah.
erroneous judgments or hallucinations, and it feels like it's going to be kind of a hybrid of a very strict human framework that then the LLM is allowed to go play in as a way of trying to increase the odds that its judgments are relevant to what their values are, aligned with their values, and decrease the odds that it just goes completely wacky and does something that would embarrass them, because they're going to be using this for 1 million transactions a month kind of thing, and they need it to scale.
Hmm. Yeah.
But I also wonder how we teach frames of reference from which to adjudicate values to an AI, because you need a frame of reference from which to judge your frame of reference. And then how do you know that's the right frame of reference? Well, you gotta, and
Yeah.
then you end up in an infinite regress, and it's all got to be operationalized for an AI into numbers. When IBM taught Deep Blue to play Jeopardy, they had to figure out what's the odds that our proposed best guess is right. And then they had another independent process saying, what are the odds it's just totally wrong? And they would combine those two scores to decide whether they were confident enough to go forth with an answer. And that was, Jeopardy questions are a lot of really unstructured data, but apparently eventually that made it better than humans pretty quickly.
Yeah.
I I have something to add on these. So from what you said, Chris, I think said, all this conversation, I mean, in general, in the general stage, not you specifically, I think it relies on it directs into the point of making an AI agent think as you like. Because if you want that agent to be autonomous, then is an oxymoron, because you're saying, yeah, you can think whatever you like as long as you think like I want to. So that's kind of it doesn't fly.
Right. It doesn't have any kind of freedom of its own judgment. It's
Right.
you're just telling it what to think.
Yeah,
Yeah.
so I'll give you a very example that is very I say contemporaneous right now. You know this Gemini AI? It
Yeah.
broke through the news because when, for example, you someone asked, give me a picture or tell me what a Nazi, Second World War Nazi looked like. It came up with all sort of races and etc. So that's exactly what I was talking about. So the frame of reference that you were talking about was injected in this AI, simply pre-selecting the data to analyze, and therefore to find the correlations that were not there in the real life. So essentially, the programmers provided the Gemini with a set of data that was skewed with respect to the reality in which all of us live to, so that the agent was autonomous in coming up with answers, but it was framed already in certain directions. So it was kind of what I said before. It was thought that the agent was taught to think in the way that the programmers wanted, and they achieved this faking, or at least selecting the amount of data they wanted this agent to be trained on. So yeah, that's that's what I like in this slide. It says true and autonomous, because if you leave an agent, intelligent agent, artificial agent to think, and then give answers, that would be true autonomous, because it is done hopefully just reading the data from reality with sensors or whatever. But if you prime them, then I don't know how much at that point. Yeah, it's autonomous because it does by itself, but I don't know.
Yeah, good point. Well, why don't I just I can just try to breeze through the rest of my, thanks, Luca, and
No worries.
I, so I just want to go over some of the traditional, it sounds like most people here already know about these, but so it'll probably be review, but traditional computational methods for decision making, some recent trends that I've discovered, and then we can have another talk. So here they are. I mean, you're trying to make a decision. The emphasis is on the uncertainty. So as most people know, we've got Bayesian networks, Lance already mentioned, Markov models, and Monte Carlo methods. And I think some other people can probably explain Bayesian networks better than me, but the upshot is that you try to determine what the prior probabilities are in advance, and then when things happen, then we update the graph, and the probabilities are recomputed, and the idea is to make things tractable rather than just computing an entire mass of probabilities. You only compute the ones that are actually necessary, and it makes it easy to envision what events are dependent upon other events. So the Reverend Bayes, she seems like a really interesting character. I mean, he was busying himself with the probability. He was a minister of it. Anyway, there's Bayesian networks. Markov models, again, most people have heard of this, but it seems like it's a good idea to just, a little bit of review. The main benefit of this is that you don't have to remember prior states. So whatever state you're in right now, that's all you need to be concerned with, as long as the situation adheres to Markov properties, and they're observable, hidden, autonomous, and under the control of a decision maker. Create an optimal policy. Monte Carlo, don't know that much about this, but one of the traditional means of managing uncertainty, where suppose you're faced with some kind of problem, you can tell there's rules there, but it may be difficult to determine what the rules are. So you just run a lot of different circumstances, evaluations, and then eventually the machine learns by kind of like gambling. I guess when I read Monte Carlo, I think they meant like, well, it's kind of a gambling sort of a thing. But so it's statistically determined, I think. Anyway, I haven't really worked with that. I mean, so basic good old-fashioned AI decision making, the idea, and in human behavior in general, which makes perfect sense. The goal is always to maximize the chances of the best thing happening. So if you're doing that, you're probably pretty rational. If a machine's not doing that, then it might still be okay, but this is the main goal, I think, in life. Utility being good, we're just trying to get the best thing to happen. And there's a theory of preferences too, which might be good to bear in mind. That for example, if a person prefers A to B and B to C, they prefer A to C. And so this makes things a little bit more tractable when trying to compute. And there's simple decisions, and then there's more complicated ones. And there's theories for having multiple attributes. So if you're trying to, excuse me, if you're trying to select a car, you're going to look at a bunch of different things like miles per gallon, how many people can ride comfortably in it, what's the horsepower, things like that. So there's a theory to that. And good old-fashioned AI it did a lot, and it seems like these techniques are still relevant. Satisficing is important by Herbert Simon. This is pretty old. So if you're faced with a situation that uh, lacks information, you can't really optimize. You just want something that works well enough, then you can use the theory of satisficing, which isn't concerned with an optimum. So we're not always necessarily optimizing agents. A lot of times we'll just pick the option that works well enough. I brought up information theory. It's information theory, as most people, if you looked into it, it's tough. It's got tough mathematics. And there's the famous ICSI theorem from, I think, like 20 years ago now, which tries to integrate algorithmic information theory and rewards, but is computationally intractable in the pure form. But one thing that in the Russell and Norvig AI book, they talk about this, and that's where I'm kind of basing this off of. They talk about the value of information. So if you're trying to make a decision, you want as much information as you can, but some information is more relevant than other information, and you might want to divert your plans if you know that knowing some piece of information is really going to help you. So that's kind of the main takeaway I get from that. Now I'm going to shift from some of these good old-fashioned AI methods, which I think are important, to some of the more contemporary methods I've been reading about and seeing. Use large language model as whatever is the basic movement now, as everybody knows. And I've got a couple examples coming up. And a lot of the contemporary literature that I see has to do with, the co-pilot, the AI helping the person, assisting the person, but not actually making the decisions. So I was kind of concentrating on autonomous AI decisions, for this event, because that's what's been puzzling me. But again, a lot of the literature is assisting humans. And another theme is the explainability, as just about everybody knows by now. We don't. It's usually pretty difficult to tell why the AI came up with the decision that it did. So there's the explainable XAI movement. Three main principles: transparency, interpretability, and explainability. Good luck with that. Good old-fashioned AI could, there was somebody in there entering their rules, and you could see a clear chain of inference usually. So the problem is they didn't work. Good old-fashioned AI would top off and not work that well, when the combinatorial explosion took off too much. But so there's the challenge. Anyway, one of the LLM as X efforts underway that I read about was LLM as a judge. So if you've got one LLM and you're trying to test in the fine-tuning step how well it's doing, you use another LLM to judge the output. And you can have things like pick a winner. If the LLM you're trying to test comes up with 3 or 4 solutions, the LLM that you're using as a judge can pick the winner, or score the other LLM, decide which response is best. And they claim in this paper, which I give a reference to, that their approach is basically like human judging, which they use the phrase "human is a gold standard," which it sounds kind of dangerous to start saying that. But anyway, basically what they're saying is that if you click on this link to the paper, is that they can get the LLM to do about as well as the human, and in judging at the fine-tuning step. There's other things here. LLM is a critic, and in multimodal models, this paper I read there, they are saying basically that it will improve, what they've got will improve decision making. So it's been a while since I read that. Now, Ron's son, here we've got LLM as intuition, which is kind of like, I think, what Lance said previously. And that Ron's son, it was like 20 years ago, this was one of the first neurosymbolic real neurosymbolic efforts with some bottom to it that I read about, and a lot of people have probably heard of him. But he's got kind of the bottom of his design has neural networks, and the top of it has symbolic rules. So he's got these two elements proceeding basically not exactly in parallel, but they both play off of each other. And this isn't not new again. It's pretty old. And Ron's son has published a paper here that in which he's envisioning how he could update his system's called Clarion, how he could update that so it could use the obvious power of large language models. And he likens the neural network part of his architecture to human intuition, to System 1, if you're familiar with that. And he basically, I want to read this because I think it's important what he wrote in there. He says, human intuition results from and relies on diverse, likely implicit, common sense knowledge about how the world works, including, for example, naive physics, folk psychology, folk sociology, and so on, which is what an extremely large amount of linguistic training data from diverse sources can provide. So basically, he's saying that the LLM, that's the intuition part of your judgment, which when I read that, I was yeah, he's right. I mean, you hear variations of this now, I know, but I like seeing it kind of a little more formalized in a paper. And of course, LLMs are often wrong, so is intuition. So anyway, and another contemporary method, which there's something important about this, which I wanted to bring up. A couple of things actually. And David Kelly, who Lance has met, and some of you have probably seen around, has been working on his AGI project for a while. And basically and he's also a co-organizer of the meetup, but he's never attended. But maybe, I can keep hoping he can come up, show up someday. But anyway, basically what he told me was he doesn't really care about, quote, logic and rational thinking. He wants the AI to be making decisions like people do. That's the intent. That's what he's working on. And so kind of a centerpiece of his design is the Plutchink emotional model with 8 emotional valences. And I'll bring up this. Here's the depiction. So basically, he scores the system, the goals around this variety of emotions. And he's also got biases built. Frankly, I don't completely understand this, but the important thing is that in his system, the system has the freedom to utilize, combinations of these various emotions, that he's explicitly using these to lead to a decision. He's got a pretty elaborate, I say he, but there's more than just him working on it, but he's got a pretty elaborate knowledge graph and some pretty interesting output that I've seen. So it's called ICOM. And again, it's basically the freedom of emotions that I think is the important thing here. And another team member, Curtin, who's associated with the Uplift Project, I got into a discussion with him about scalability, and it seems like, with present AI, which is very impressive, but you kind of wonder where it's going to top off, where it hasn't been exposed to, some circumstance in question. What's it going to do then? And it brings up the important issue of scalability, because it seems like we have this capacity to, okay, even if we haven't seen some specific circumstance, we can still kind of construct an outline of what's going to happen, and that scalability is an important aspect. And it brings up the and Curtin's Curtin, sorry, I didn't pronounce his name right, but anyway, in his he published a paper, and he's got this great depiction. Okay, suppose you've got, and I'm not sure if this is exactly the way he put it, but suppose you've got an AI system that hasn't been trained on a cat. You describe the cat to it, And can the AI system scale up with no prior knowledge at all to an image of a cat? Well, yeah, it should. But and I know this is bringing to mind diffusion theory and stuff like that. But the point is that suppose the AI is not challenged with a picture of a cat, which is pretty simple, but is challenged with trying to understand some kind of unique judgment that has a lot of uncertainty to it, and there's no training in advance. Can it construct some kind of silhouette of the situation, like the cat here? Can it do it or not? It's a puzzler. I don't have the answer, but I mean, it's just something to keep in mind. And the last topic I want to bring up under contemporary methods, decision making under deep uncertainty, which is not exactly new, but I came across it. I forget who wrote a article on Medium. I can find the reference somewhere, but the author was saying, well, what does happen in complex judgments? Can we use decision making under deep uncertainty? Which I think this is 10 or 20. It's probably 20 years old in academic circles, and I hadn't known about this previously. But this is where I got that quote that I read previously, and it's there if you guys want to read it later. But the main emphasis here is on if you've got a situation with, a really complex situation with a lot of uncertainty, how do you get away without making the worst, without having the negative consequences come into play? So it's tools. It's not automation per se, really. It's more like a bunch of tools that you can utilize to try to work a complex problem. Like, I think they were using global warming as an example of a pretty serious problem. How do you avoid the worst things happening? But it doesn't have to be that dramatic of a problem. Excuse me. It could just be a more mundane problem. But suppose you just don't want suppose you've got a robot that's supposed to do something in manufacturing, but you don't want it to crush somebody. That's the worst outcome. That's probably a bad example, but anyway. So now we're going to move on. This is the discussion phase that at least that I had envisioned. And the kind of my own goal was to try to envision what some of these challenges are, and then maybe some kind of tools or design goals that we could use to fix some of the challenges, like good old-fashioned AI. It seems like would still be applicable to just general uncertainty, Bayesian networks, stuff like that. I don't know if the way it is right now, you just feed everything into the large language model, so you tell it how to do Bayesian networks, feed that in first. I don't know. Hallucinations, again, good understanding and reasoning. If the system doesn't really understand what it's doing, or it can't reason, the judgments are going to be pretty bad anyway. So it's still an important part. It's hard to in AI to abstract, some piece of mental processing, because everything is so connected. Like Jim Bromer told me once, there is no such thing as an independent concept. So the minute you start talking about something in isolation, you're automatically talking about everything else. So scalability, negative outcomes. Like we could, maybe use some methods from what I've had. Decision making under deep uncertainty is what I was looking for. Intuition, LLM is intuition. And then this has been talked about already, freedom of action and volitional freedom. So if you're telling the AI what to do, if you're sitting there programming in exactly what to think, I don't see how it can actually make a true judgment. Now, that doesn't mean we should let it get away with any judgment. So what it does is really important. I don't mean to say that we should just let it do whatever it wants to. But it can think of the worst things, though. It can cogitate over